Okay, so we have a question here. Question one, it says for the production function Q equals 250k, the power 1 over 4, power 2 over 3. Find the output when k equals 81 and L equals 27. So this production function, it's taken from economics. Okay. K, what K stands for is capital. L stands for labor. Okay, so your productivity is dependent on your capital and your labor. So we want to find out the total output when we have 81 units of capital and 27 units of labor. So colleagues, for this one, it's not that difficult. It's just a matter of substitution. So we're going to say Q equals 250 K to the power 1 over 4 L to the power 2 over 3. So they told us when K equals 81 and L equals 27. So we just substitute K with 81. So 250 times, substitute K with 81. 81 to the power 1 over 4 multiplied by L, that is how many units? 27 units. 27 to the power 2 over 3. Okay, so this is where we need to apply some indices because we've got fractional exponents here. Okay, so we need to simplify two these two terms. Okay, so 81. Okay, it's the same as 9 times 9. Remember, 9 times 9 equals 81. So 81 you can write it as 9 squared. Okay, 9 squared to the power 1 over 4. Then you can multiply these 2 times 1 over 4. What is 2 times 1 over 4? That is 1 over 2. Then according to the laws of indices, m over n, a to the power m over n is the same as the square root of n, a to the power m. Okay, this is a law of indices. We would have applied it also here. I just wanted to simplify further. Okay, but we could have even applied it from here. Okay, because the fourth root of 81 is just 3. Okay, yes. So here, 9 to the power half is the same as getting the square root of 9 then to the power 1. What is the square root of 9? 3. Okay, so this 81 to the power 1 over 4, when you break it down, it becomes 3. The other way would have done it, 81 to the power 1 over 4, according to the laws of indices. So the fourth root of 81 to the power 1. The fourth root of 81 is 3. Okay. Any questions? So this 81 to the power 1 over 4 becomes 3. We go to 27 to the power 2 over 3. All right. So 27 also if you break it down, it's the same as saying, oh, we can just apply this law of indices here. No need to even break it down. So basically, we need to get the cube root of 27, then we square it. Okay. The cube root of 27 is 3. 3 times 3 times 3, that is 27. Okay. Then 3 squared, that gives us 9. Oh, the other way we would have done it. 27, since we say it is 3 to the power 3, put it like this. 3 to the power 3, then here 2 over 3. When you multiply 3 times 2 over 3, these 3's cancel. Remain with 3 to the power 2. 3 to the power 2 equals 9. Any questions, colleagues? Okay, let's get our calculators. 250 times 3 times 9. 6,750. So this is how many units they produce. Okay. 6,750 units. Any questions? Okay, we go to the next question. Simplify the square root of 243 minus the square root of 12 plus the square root of 275. Okay, so this topic is on surds. Two 43 minus the square root of 12 plus 2 square root of 75. So colleagues, whenever you see a question like this, okay, what you need to do in these roots, you need to get the smallest prime factor for each of these numbers. You have to find the smallest common prime factor, basically. Remember, what are factors in mathematics, colleagues? A factor that is a number that is divisible by another number and cannot leave a remainder. So here we have to find what is the common prime factor, not prime factor, what is the common fact when I'm focusing only on prime factors. What is the common factor between 243, 12, and 75? 3, yes. So we have to find a way to have a 3 in each of these roots. Okay, so we have to first simplify these roots. Okay. Once we have a 3 in each of these roots, then we can add them or subtract them. But the way they are, you can't add or subtract. They all have to have the same number here. So the smallest common factor is 3. Okay, so let's start with 243. Let's break it down first. 243 divided by 3, that is 81. Okay. This 243 can be broken down into 81 times 3. Okay. So here we can see we've got a perfect square, 81. Okay. So this can be broken down further into this. Square root of 81 multiplied by the square root of 3. Okay. The square root of 81 multiplied by the square root of 3. Okay. We've split this into these two components here. What is the square root of 81? What is the square root of 81, colleagues? 9. Yes. So 9, then you put square root of 3. Since 3 hasn't got a square root, so you just leave it as it is here. But 81, you can square it. So you've got a 9. Any questions before we move further? Next, we go to 12. Okay. 12 divided by 3, that is 4. So this can be simplified into the square root of 4 times 3. Okay. Again, here we've got a perfect square, which is 4. So we can split this. It becomes the square root of 4 multiplied by the square root of 3. What is the square root of 4? Next, we come to 75. Okay. 3 divided by 75, it's 25. This can be split into the square root of 25 multiplied by the square root of 3. Square root of 25 is 5. Okay, so we have plus 2. These 2 outside multiplied by that 5 which you got as the square root of 25. 5 multiplied by the square root of 3. Okay. 2 times 5, that is 10. So here, this simplifies to 10 square root of 3. Okay. So now as you can see, we have got 3's in the roots. So now we can add and subtract here. Okay. So it's basically saying 9 minus 2 plus 10, what do we get? These 3's will remain as they are. Okay. Think of it like 9x minus 2x plus 10x. Okay, these 3's, they'll just stay whatever they are. Okay. So 9 minus 2, that is 7. 7 plus 10, that is 17. So that's the answer. 17 square root 3. Any questions? You look for one. Okay, let me maybe let me see because your example I haven't yet. I'm not understanding it. You're saying, mm, you just remember this, okay? When you're given such a question, just look for the smallest common factor so that you have an idea of, okay, what number should I see in the roots here? Okay. Yes, yes, you can use also that other number, but eventually you'll still come down to the same answers. I believe eventually you can come to the same answers. But like in this case here, apart from three, I don't think there's any other common factor between these numbers. There was someone who raised their hand up. Well, someone, yes. Mm-hmm. Did someone raise their hand again? Okay, we go to the next question. Now just so even these surds they've got laws. So I also share with you the laws of surds. Okay, they've also got laws which you need to remember. Okay, so let's look at the next question for logarithms. Let me just bring the question onto the board. So indices, logarithms, you need to remember these laws. Okay, so solve for x given log x plus 2 equals log x minus 4 plus log 3. Okay, so here from this equation, let me give here the laws here. You've got this rule here. Okay, whenever you see an equation for logarithms where there's an addition sign here, remember this rule number one. Have you seen here? The log of b m multiplied by n is the same as the log of b, m plus log of b n. Okay, so here with this equation here, it's like we're starting, if we look at row 1, we're starting from here. And then we're moving back to this here. Okay, because what we want to do for this equation, we need to first get rid of the logarithms. Once we get rid of the logarithms, then we can solve it like a normal algebraic equation. So usually when they give you equations with logarithms, if you see a plus sign, like how it is here, apply the product rule, which is rule number 1 here. Okay, so if we apply the product rule, first it starts like this: log x plus 2 equals log x minus 4 plus log 3. So if we apply the product rule, this expression log x minus 4 plus log 3 becomes log 3 multiplied by x minus 4. If you want, you can write x minus 4 multiplied by 3. Okay, we've just applied this rule 1 here. All right, as you've seen, we're moving from here back to this. So that's how we've now remained with log, open brackets, 3 multiplied by x minus 4. Any questions before we go to the next step? If this was a minus sign here, we would have applied rule number 2, where we say log x minus 4. We would have made it log x minus 4 divided by 3. All right. So with these logarithmic equations, first thing, make sure everything is in the same log. Here, since it's just written as the word as log, so it's in log 10. Here, log 10, log 10. After that, now you apply any of these rules. Okay, so since it's an addition sign, we have to apply the product rule. That's how we've come with log 3 multiplied by x minus 4. Once we reach this part, you just get rid of the logarithms now, so that you remain with purely algebraic expressions. So this becomes x plus 2 equals 3 times x, 3x, 3 times negative 4, that gives us negative 12. So here, all in all, what we wanted to do is wanted to get rid of the logarithms. Once we get rid of the logarithms, then now we can solve. This has become a normal algebra equation. So it's just a matter of like terms, grouping like terms. So this positive 2 can go over this equal sign, or we want x to be positive. So this x can cross over. And this negative 12 also can cross over. So we're going to have 2. The negative 12 crosses over, it becomes positive, plus 12 equals 3x. When this x crosses over, it becomes negative x. Two plus 12, 14. 3x minus x, that gives us 2x. To get the value of x, divide both sides by 2. 14 divided by 2, that is 7. So our value of x is 7. Any questions? So when you see such a type of equation, make sure first the logarithm base is the same. Okay. After that, next thing you need to get rid of the logarithms. So one of these rules, the equation will be in a format where you can either apply the product rule or the quotient rule. In this case, if you see a plus, you're doing the product rule. As you can see, you combine the numbers here, you multiply the numbers. Okay. Once you've applied the product or the quotient rule, then you get rid of the logarithms on both sides. When you get rid of the logarithms, then you can solve it like a normal algebraic equation. Yes, questions, queries? Before we move to the next one. Okay, the next question, solve, this one is a quadratic equation, x squared plus 2x minus 8. Yes, so when you're dealing with quadratic equations, label your leading coefficient, which is a. Our leading coefficient for this x squared is 1. Okay. We label your coefficient of x, which is also called b. The coefficient of x is 2. Then you label your constant. Basically, it's the number without a letter. Okay. A represents coefficient of x squared. Okay. A is the coefficient of x squared. B is the coefficient of x. And C is just this number without any letter, the constant. Okay. Now, once if you're already comfortable with quadratic equations, you don't really need to go these steps, label A and whatever. You don't need to go with other steps. But I'm just doing it for those who might have forgotten how to solve. Okay. I'm doing the step-by-step way. So you're going to multiply A times C, 1 times negative 8, and gives you negative 8. So you're going to look for two factors of negative 8, that when you multiply those two factors, they should give you negative 8. And when you add those two factors, they should give you positive 2. Okay. So the factors of 8 are 4 and 2. So if we make this 4 negative, actually if we make the 2 negative, 4 times negative 2, negative 8. 4 plus negative 2, it is this 2 here. Any questions? Now once you found those factors, you just write it like this: x plus 4 x minus 2 equals 0. And you solve. X plus 4 equals 0. You take 4 to the other side, x becomes negative 4. So x equals negative 4. Or x minus 2 equals 0. You take this negative 2 over the other side, becomes positive 2. So x equals 2. Okay, so these are your solutions. X equals negative 4 or x equals 2. Any questions? Any questions or queries? Okay, we go to the next one. Solve the equation log x squared equals log x squared. So we have to find the value of x basically. Log x squared equals log x squared. Okay, we have to find the value of x. So first things first, we need to get rid of this power 2 for this x here, because we want it to remain as log x. Okay, so we need to get rid of this power rule. Okay, so you need to get rid of this power. So we apply the power rule for logarithms. Okay, as you can see here, this rule number 3, when you have a power, just bring it in front of the logarithm. Okay, so that's rule number 3. Okay, so that's what's going to happen there. Whenever you have a power, just bring it in front of the logarithm. Okay, so it's going to become, we're going to have now 2 log x equals log x squared Okay, so what we need to do next is we need to bring this over this equal sign. Actually, no, since it become negative. So this 2 log x, we take it to the left, the right hand side. So 2 log x, we're going to take it over the equal sign. Okay, because these are like terms. There's a log x here, there's a log x. So you're going to have log x squared minus 2 log x. Okay, basically equal to 0. Okay, now I'll show you there are 2 ways we can solve this one. I'll show you both methods, then you're going to choose which one. Okay, which one you prefer with. Okay, so here you can factorize this expression. Okay, because we've got a common factor here. Our common factor is log x. Okay, so say log x, which is our common factor here. Remove it out of the brackets. So log x squared divided by log x, you're going to get log x. Okay, log x squared divided by log x, you get log x. Minus 2 log x divided by log x, you're going to get 2. Okay, here I've just factorized. Okay, the common factor was log x, and I've just divided log x by each element so that I simplify my expression. Okay, so here we can set up 2 equations. The first equation is log x equals 0. Okay, and the second one, log x minus 2 equals 0. Remember, here we want to find the value of x. Okay, we want to find the value of x. Yes. And as I said, when you see a logarithm like this, when you just see it's written as log, it's to the base 10. Okay, it's log base 10. Okay, so let me just write one rule how we can transform logarithms into exponents. Log b y equals x. Therefore, y equals b to the power x. Okay, what I've written here on top here. Okay, when you want to convert logarithm into an exponent like this, okay, you just get the base of the logarithm, attach it with a number on the other side. The other number that's going to be on the other side will be the power. Okay, and then whatever letter you have here is going to be on the left hand side, basically. So basically here, this is like log 10 x equals 0. So this 10, you attach it to this power 0 there. Okay, so this side we get 10 to the power 0. Then this x, it stays on the left hand side. As you have seen here on top, this y stayed here on the left hand side. Then the b got attached to whatever number is on the other equal side there. Okay. So 10 to the power 0 is 1. So this is our first solution. X equals 1. Any questions before I move further? Similar to this one here, log x minus 2 equals 0. You take, become log x equals, this 2 goes over the negative sign, becomes positive 2. Okay, then when we apply this, since here there's the base is 10, so you take this 10 here, so it's going to be 10 squared on this side. This x, you bring it down here. So x equals 10 squared. 10 squared, that gives us 100. So the values of x are x equals 1 or x equals 100. That is method 1. Any questions before we go to method 2? Method 2, we will still have to do the same thing. First, get rid of this power 2 for x, bring it in front. 2 log x equals log x squared. Okay. Then you need to bring it back into, put it in this equation form. Log x squared minus 2 log x equals 0. So this is in the format of a quadratic equation. Okay. It's in the format of a quadratic equation. This expression, log x squared minus 2 log x, is in the format of the quadratic equation. So you can solve this quadratic equation by substitution. Okay, you can solve it by substitution. So with substitution, since we've seen this log x is common here, so we can say, okay, we can pick a variable. You can say let y equal log x. All right. Therefore, if you square y, it becomes also log x squared. Okay. So this log x squared, substitute it with y squared, minus this log x, substitute it with y. So it's y squared minus 2y equals 0. Okay. This is solving by substitution for quadratic equations. Okay, because there'll be times where your variables won't be just a simple x and y. So you can substitute with a simple variable, then you can solve later on. So here we have y squared minus 2y equals 0. Okay. So again, the way we did this one previously, our common factor here, it is y. So we put y outside. Y squared divided by y, minus 2y divided by y, that is 2, equals 0. Okay, so we have two solutions here. Y equals 0, or y minus 2 equals 0. Therefore, y equals 2. Now we're not yet done, okay? Because once you find the values of these variables, you found what y equals. We go back to what we said earlier on. We said y equals log x, right? So if you substitute y with log x, you come back to this. You have log x equals 0. If you come to this other side, substitute y with log x, again you have log x equals 2. Okay. Now I want to find the value of x. So we're going to apply again this rule here. This log, the base is 10. So you take this base with the number on this side, so it becomes 10 to the power 0. And this x, bring it down here. So x equals 10 to the power 0. 10 to the power 0, that is 1. So you say x equals 1. On the other side, log x equals 2. Again, this is log, the base is 10. You take the base, this becomes 10 squared. Then you bring x here. X equals 10 squared. That gives us 100. Yes. So colleagues, which one do you feel is better? Where you substitute, work with a simple variable, or you just solve as it is, taking in mind that, okay, this will be my variable that I'll be dealing with.